Okay, our content standards for solving quadratic equations by graphing, ACED2, and for functions, FIF4. We'll have one mathematical practice we'll focus on the assignment, which will be 3. Construct viable arguments and critique the reasoning of others. Previously, you solved systems of equations by graphing. That's what we did in section 4.1. Now we're going to solve quadratic equations by graphing and estimate solutions of quadratic equations by graphing. New vocabulary. There's 4 different words: quadratic equation, standard form, root, and zero. Some things you need to know: quadratic equations are quadratic functions that are set equal to a value. So the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a is not equal to 0 and a and b and c are all integers. Now the solutions of a quadratic equation are called the roots of the equation. One method for finding the roots of a quadratic equation is to find the zeros of the related quadratic function. Now the zeros are simply where the graph intercepts the x-axis. Alright, so this is what it'll look like if we have 2 real solutions. Our quadratic equation, x squared plus 6x plus 8 equals 0, that's in standard form. We're going to solve this one by graphing. Now, the equation of the axis of symmetry, so if we take negative b over 2a, so negative 6 over 2 times 1, or 6 divided by 2, that's going to give us that negative 3. So when we're graphing, when we're picking our points to put in our table of values, we want it to be symmetric around that negative 3. That helps us pick our values. So we're going to make our table of x values around negative 3. Then we're going to graph each point. So notice, if we pick negative 3, then values on either side of it. We're trying to find the same distance. This is one direction from 3. This is 1 the other direction from 3. This one is a negative 1 is 2 from a negative 3, and a negative 5 is also 2 from a negative 3. So we can see that symmetry we've got going. That's how they pick the 5 points. So when we graph that one, notice the zeros. This is where it crosses the x at a negative 4 and at a negative 2. So those are the zeros, or those are solutions, the roots of the function. So the solutions of the equation are negative 4 and negative 2. Then you can check your solutions by substituting each solution into the original equation. So to see if they really are true solutions, you're going to substitute a negative 4 in on this one, negative 2 on this side, and sure enough, we got a check. Now the graph of the related function in this example 1 has 2 zeros. Therefore, this quadratic equation has 2 real solutions. That is one of 3 possible outcomes when solving a quadratic equation. So let's look at check your progress. So see which one of these might be the graph of that equation. I'll let you pause for just a moment, then come back and check your answer. Well, did you figure out the axis of symmetry, the x-intercept? So negative, and then if you do 2 over 2 times 1, you're going to have negative 1. So you know that the vertex, the x value, is going to be negative 1. And also, this tells you it's a positive. So these 2 are ruled out immediately because those both have negative. This one's positive, but you know that your vertex is going to be where x is negative 1. So you don't have to do the whole table of values. There's little things you can do to cut the time out. Now, the 3 different kinds of solutions we're talking about on a quadratic equation, the first one we did had 2 solutions. You could have 1 real solution, or it may not ever touch that x-axis, so you could possibly have no real solutions. So let's look at what some of these would be. 1 real solution. Okay, well, the first thing we need to do is get this one in standard form. So let's add 4 to both sides. So we've got a standard form of the equation. Then we're going to graph this related quadratic function. So here's a table of values they've chosen. Notice that the graph has only one x-intercept, and that's at 2. So the only solution to this one is 2. Time for you to check your progress. So pause for a moment and see what you get for this one. Did you start by adding 9 to both sides so you can get it standard form? And then our negative b over 2a, so the opposite of negative 6 over 2 times 1. So negative 6 divided by 2 is a negative 3, but the opposite would be a positive 3. So we know that we're going to have a vertex where x is 3. This one's a positive slope. Okay, that one's negative, that one's negative. This one, oh, nope, it's not a positive 3, so our only choice was A. Now it's possible to have no real solution. So let's look at our number theory. We're going to use a quadratic equation to find two numbers with a sum of 4 and a product of 5. So if we let x be one of the numbers, and we know it's got a sum of 4, so if we take x and subtract it from 4, that would be the other number, right? 4 minus x. And we know that both of them are equal to 5. So we use the distributive property. We're going to, I wonder why they added 5. This should have been subtracting 5. Then they're going to graph that function. The graph has no x-intercepts. This means that the original equation has no real solution. So it is not possible for two real numbers to have a sum of 4 and a product of 5. So to check, you try to find the product of several numbers whose sum is 4. So like, look at 2 and 2 and 3 and 1. So 2 plus 2 is 4, but is 2 times 2 5? 1 plus 3 is 4, but is 1 times 3 5? No. Not working, is it? Time for you to check your progress. So use a quadratic equation to find two numbers with a sum of 4 and a product of 14. Very good. There are no set numbers. Such numbers exist. Now we can also estimate solutions. Often exact roots cannot be found by graphing, but you can estimate the solutions by stating the integers between which the roots are. Make a table of values and graph the related function. Okay, the x-intercepts of the graph are between 0 and 1 and between 3 and 4. So one of the solutions is going to fall between 0 and 1 and the other is going to fall between 3 and 4. So we're just estimating the roots. Okay, time for you to check your progress. So pause the video for a moment, then come back and check your answer. Okay, the consecutive integers between which the roots are located, they fall between 0, 1 and 3 and 4. Okay, final example. We're going to solve by using a table. Okay, so if you were to enter this in, use your function editor and enter the equation into your graphing calculator. And then after you get it entered, then of course you can use that table window, which we've done. You're going to change the table to 0.1 and look again for the sign change. Okay, so replace the process with 0.01 and 0.001 to get a more accurate location of the 0. So this is what it looked like on your graphing calculator. So y sub 1, notice here we've got our equation. So one solution is at approximately 1.140. See where it changes sign? Okay, so time for you to check your progress. Locate the 0 in the function from example 5. negative 6.140. Okay, very good. So many of you don't have a calculator, so I'm going to just sort of go over this briefly for those of you that do and like the extra challenge. But those of you that don't have a graphing calculator, we don't need to worry about this so much. I'll give you time just to look through the problem here. Okay, so we need to find t when h of 0 is 1056 and h of t is equal to 0. Okay. So 0 is equal to negative 16t squared plus 1056. So you're going to graph that function. Now just because it says t, that shouldn't be a problem. If you just use that variable key, it doesn't matter if it's t or x or what. You may have to adjust your window so that the x-intercepts are visible. So you might have to adjust your x-min or your x-max. Then to use the 0 feature, second calc, to find the positive 0 of the function, since time cannot be negative, use the arrow keys to locate a left bound for the 0 and press enter. Then locate a right bound and press enter twice. There you go. The positive 0 of the function is approximately 8. It should take about 8 seconds for the marble to reach the surface of the water. There you go. Okay, check your progress. So about 7 seconds is the time in seconds for it to reach the surface of the water, assuming there is no air resistance. Okay, you're ready to begin your assignment.